Tunneling with no encryption? Well, why the heck would we use it? Well, find out next, right here on IT Pro TV.
You're watching IT Pro TV.
We are taking a look at GRE tunnels, and here to help us to dig through the situation, Mr. Anthony Sequeira. Anthony, so I teased this as we opened it. GRE offers no encryption.
That's right.
It gives us tunneling. Why the heck would I choose to use it?
Yeah, this is what I call the duct tape of
Tunnels.
networking. Yeah, there's two tools that we just, I like consider them duct tape. One silver, one gray, or what's the other color they'll use with duct tape. And notice I'm saying it right.
Yes.
Right? It's not duck tape.
They do. There is an actual duct tape brand.
Oh, there is.
Yeah,
All right.
so there you
Just
go.
learned something. But yeah, I always am thinking of duct tape, which is the tape that I used to have to use when my father would shove me in the attic to help with the AC installations.
Ooh, I'm glad you said that.
Not a good job. That's why I learned tech. So there was duct tape we would use on the duct work. Okay. Route maps and tools like GRE, I consider like duct tape. Like Ronnie says to me, Anthony, I need to send this traffic from point A to point B, but I got a problem. Multicast isn't supported. I go, GRE to the rescue. Let's wrap it in GRE, the multicast traffic, and send it. And that'll be unicast that your topology can support. Or some crazy thing like this. You're in an exam environment and they show you a topology. Let's take a look at this little sample topology I have right here, Ronnie. They go, all right, Ronnie, we got a weird one for you. R1 needs to EBGP peer with R4.
All right.
And you can't use the EBGP multi-hop command.
Oh.
That's against the security policy. And you go,
Yeah. How?
well, I can't do it.
Right.
I mean, an EBGP peering needs to be a direct connection or it's no good. With, that the EBGP multi-op is how we would get around that. And they're taking that away from me. GRE to the rescue, the duct tape, allowing us to go ahead and create what appears to be a point-to-point link from R1 to R4, this GRE tunnel. Now there is a direct connection according to the routers. What do you say we try it?
Yeah, sounds great.
So GRE is super easy to configure. Let me prove it to you. We're going to go to R1. This will be one of the tunnel endpoints. And the first thing you do is you say, I want to create a tunnel and pick a number. Obviously, just make sure that number isn't already used. Now we get some guidance from the router. I love it. It says, okay, the line protocol is down. Why I love this is if I make the tunnel correctly, we should see it come up. I love when we get immediate verification like that. It's kind of like instant gratification. So we're going to go in and we're going to say, by the way, you don't have to say tunnel mode and pick GRE because that's the default tunnel mode.
Okay.
So no need to specify the tunnel mode. You can go right in and you can say, this is what you should do first, IP address. Your tunnel is going to get a layer 3 IP address, and this is address space that you can really pull out of thin air. So I don't have the 172.16 range anywhere in our topology. Let me use that. This end of the tunnel will be 172.16 1.1, and I'll drop in a 24-bit mask. Now we say tunnel source. What is the source of our tunnel? We love to use loopbacks when we're doing things like this between routers. So I'll say the tunnel source will be our loopback of 192.168.0.1. The tunnel destination will be 192.168.0.4.
All right, so before you go on, why did you choose to loop back as a source? Because I'm probably asking that question to so are people as they watch it for the first time.
It reminds me of like in BGP or any of these technologies where you want to always be able to get to that location.
Okay.
using potentially multiple paths, the loopbacks are awesome for that, aren't they?
Yep.
Because if they're in the database, if there's routing awareness about them, then they're like the endpoint you can get to potentially over many physical interfaces.
Right.
So it's a great availability feature, really. Look what happened. I must be doing good work here because the tunnel just came up. So when you have a functional tunnel source and tunnel destination, then the tunnel's going to come up. A common mistake would be that you can't reach the tunnel destination. But as you can see there with my ping, I can reach the tunnel destination. And that's why the tunnel came up. All right, we're going to end this configuration and we're going to slide over to the other tunnel endpoint. And if you could do one side, I'm betting you can do the other. Interface tunnel, my favorite number. And I'm going to say IP address is 172.16.1.2. Notice they're on the same segment together, but they have unique host IDs, 255, 255, 255.0. My tunnel source is my loopback 192.168.0.4. Yes, you could use interface references here instead of the IP addresses, but I love using the IP addresses. The tunnel destination is 192.168.0.1. If I did this right, I should see the tunnel come up. It just came up. This is awesome. And now if I do a show IP route on this device, we should see that we have this 172.16. I've got a new local interface entry, and it is for our host route for the 172.16.1.2. We now have what appears to be, Ronnie, a point-to-point connection between those two devices, and we can solve what looked like an impossible task. I can go in and I can say router BGP, and we'll do AS65400 here, and I will do neighbor 19. Let's do the tunnel address 172.16.1.1. And did I spell neighbor correctly? That's sure. No,
yes.
It looks wrong, but it's right. Neighbor 172.16.1.1. The remote AS will be 65.100. So that is an eBGP peering. And now I'm going to go over to the R1 and I'm going to say router BGP 65.100. We want a neighbor with 172.16.1.2 in remote AS 65.400. And drum roll. I wonder if this is going to work. We are attempting to eBGP peer. We are not directly connected. We're trying to do it over this tunnel. Going to be super interesting to see if this works. Show IP BGP summary. It worked. Wow. How do we know it worked? Well, as we'll cover in our exploration of BGP, we have a, whoa, I just highlighted everything on screen. We have a prefix indication over here as opposed to a state. And I'm like, why didn't we see a console message? And I missed it, Ronnie. There it is. Yep. I think it occurred right when I did the show IP. So, wow, look at that. Path virtualization. We have a situation where we've got two devices and they are not directly connected, and we just virtualize things so that they appear directly connected. You know what another classic like super challenge is on this one? OSPF. You tell somebody, connect that area over there to the backbone, and you can't use a virtual link. And they go, oh my gosh, what am I going to do?
GRE?
Oh, GRE.
Okay.
Make a nice tunnel connecting them to the backbone and run your OSPF over that. Now, there is one classic danger about these GRE tunnels and routing. And that's the famous recursive routing situation.
Okay.
That was not an issue for us because we built the tunnel. Sure, OSPF made the tunnel possible, but then we didn't run OSPF over the tunnel. We did BGP. Just be careful about how you do that. The basic rule is that the tunnel can't be constructed based on a routing protocol that you're setting up the tunnel for. In other words, there has to be some separation there. You can't have a routing protocol working over the tunnel that relies on the tunnel. Does that make sense, Ronnie?
Yes.
Like, yeah, you want that separation. Oftentimes we'll go in with static routes to make sure the tunnel endpoints work, and then we drop in a routing protocol so there isn't this like chicken and the egg problem. You know, OSPF is needed to bring up the tunnel, but the tunnel is for OSPF.
Yeah.
And that gets into that recursion problem.
So let me try and reset the context just a little bit, and maybe you can help us out.
Sure.
Can we do something like this over, let's say, like the internet, a GRE tunnel?
Absolutely.
Over the internet?
GRE is super, super flexible. Remember, it's that duct tape. It can just add encapsulation, simple encapsulation over any traffic for a wide variety of purposes. And Ronnie, you might have some device that disallows it, but it's very rare to run into that.
Yeah, where I found the most use of it, at least in my experience, is over MPLS, is where I found the most use
Sure.
of it. Because of the technology that's different there, but we needed the ability to run that traffic through it as if that didn't exist.
Yeah.
Essentially is what happened.
And you know what's funny? This is a recurring theme in Encore, right? You look at GRE and you're like, that's old news. But then you think multi-point GRE.
Right.
You and I were talking about that last night. Multi-point GRE is one of the key technologies in dynamic multi-point VPNs. One of Cisco's most popular and successful inventions ever. So never like look at some protocol and go, poor little lame thing that we used to do 20 years ago. You just never know when a technology like GRE is going to come roaring back, just like it did in DMVPNs.
Yeah, so to make sense of that, maybe that's the first time people might have heard about that particular term so far. This is multi-point VPN is when we actually have more than one endpoint. So what we essentially did here was really kind of a point-to-point.
That's right.
So dynamic multi-point is actually them being able to actually go from almost like a hub and spoke network just about, right?
Yes, you got it. And you know what I just decided? This episode, you're the first to hear it. I'm bringing RIP back. I am bringing RIP back.
Well, if you can bring ISIS back, I guess you can bring RIP back.
That's exactly right.
So there's no doubt about it.
Bringing RIP back. RIP version 10.
RIP version 10. All right. Well, since they're only up to version 2, there's a lot to catch up on.
Right.
All right. Well, Anthony, thank you again for helping us to understand a little bit more about GRE tunnels, especially the context. If you're not familiar with the technology, then us just throwing more information at you is not going to help. Anthony set up the context of when we might use them and actually great examples of when you might find them on the exam, as well as in real life too, to make sure you pay attention to that too as well. Now, the configuration you notice is not really difficult. It's fairly easy, but Anthony did give us that warning. Don't base it on the same protocol that needs the tunnel or the tunnel needs the protocol, whatever it might be. Don't base it on the same thing. Make sure you actually take a look at that before you set everything up. Well, there is more to come on path virtualization, but that is enough for our idea of course, what we've been talking about here. So we are going to go ahead and sign off. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.